Hi, my name is Rodrigo Garcia, and I'll be going over Inmarsat and its place in aeronautical communications worldwide. Nowadays, our ATM infrastructure is suffering from heavy communication frequency congestion in continental areas such as North America and Europe. For this reason, international organizations and ATM service providers are looking for new ways to deal with this problem. In this presentation, I'll be evaluating Inmarsat as an option, while explaining the services it provides, such as Swiftbroadband and Classic Aero. Inmarsat is one of the largest mobile satellite service providers in the world. It provides data and voice communication services to almost every sector, including civil aviation and military. Inmarsat is a leader in aeronautical mobile satellite service and is used in voice and data exchanges for ATC, AOC, APC, and AAC services. Inmarsat was established in 1979 as an intergovernmental association in order to provide maritime communications due to the lack of coverage in oceanic regions. It was later also used in civil aviation as suggested by ICAO. In 1999, Inmarsat was privatized and became the first private satellite service provider in the world. In 2005, they launched the first of Inmarsat's I-4 series satellites, which would complete its constellation in 2008 and would later operate Swiftbroadband and Classic Aero networks. Swiftbroadband is currently the next ongoing step in satellite communications. Initiating its service in 2007, this network operates through data link architecture for air and ground communications. It is an IP protocol-based multiple-channel system capable of up to 4 simultaneous channels of about 432 kilobits per second each, depending on the type of antenna and the avionics carried by the aircraft. Swiftbroadband also provides backwards compatibility with other Inmarsat communication services to provide reliable communications to everyone. Swiftbroadband service allows for many applications due to its efficiency and reliability in terms of coverage and high broadband capacity. Among these applications, there's the cockpit communication and navigation services such as ACARS messaging. This is a fundamental implementation, as the ability to communicate from any point in the world, regardless of being in a continental or oceanic region, is in a reliable way thanks to the worldwide coverage of Swiftbroadband, provides substantial safety benefits in both civil and military aviation. It also provides services such as controller-pilot data link communications, which allows for ATC communications, although this still hasn't been approved for Swiftbroadband. Swiftbroadband also allows for automatic dependent surveillance, which allows pilots to determine their location via satellite aid anywhere on Earth. Other cockpit applications to this network are its use for voice communications. Swiftbroadband provides high-quality voice services, allowing for multiple voice lines, which can be used in parallel to other data-based communication services. An application that is increasingly useful in civil aviation is its use to receive at any point flight information services such as weather forecasts, chart updates, flight plans, and others via data link communications. More consumer and business-oriented or cabin applications for the use of this network are APC data services. This includes services such as internet, email, video conferences, and voice over IP using your phone. Overall, any type of IP streaming service with a capacity limit of up to 1 channel or 432 kilobits per second. This limit can be bypassed nevertheless by hardware and software produced by affiliate companies such as Satcom1 and their Avio IP software, which allows for channel bonding and thus increasing bandwidth capacity. Finally, Swiftbroadband allows for a wide array of operational applications, some of which include reliable aircraft tracking due to their always-on data relay system and worldwide coverage, AOC services such as field control and de-icing control. The Swiftbroadband system operates using Inmarsat's I-4 satellite series constellation network and the later launched AlphaSat satellite. This constellation is composed of 3 I-4 series geostationary satellites located along the equator in order to obtain coverage of the entire Earth, and the AlphaSat, which allows not only for complete coverage of the European and African regions, but also provides a number of improvements on the Swiftbroadband system. These satellites operate in the L-band, which has a frequency range of 1 to 2 GHz, which allows for efficient communications. In satellite communications, and most commonly in geosatellites, in order to increase communication signal capacity in its footprint without actually increasing its frequency range, a satellite will focus its signal to a specific area of its footprint, increasing its concentrated power. This is done by a high-gain antenna in the satellite, known as a spot beam. The innovation of this technology allows us to reuse frequencies as long as the spot beams don't overlap, because if they do, they are likely to interfere and reduce the signal's integrity and reliability. Inmarsat's Swiftbroadband exploits this technology by essentially making a net of spot beams throughout the satellite's footprint, thus increasing an area's frequency capacity exponentially depending on how concentrated the spot beams are made. In terms of avionics, Swiftbroadband relies on FANS 1A devices to provide cockpit with direct data link communications between pilot and controller for ATC communication. The antennas that allow for the use of Inmarsat Swiftbroadband voice and data services are the high-gain antenna, the intermediate gain antenna, and the famous Swiftbroadband 200. Classic Aero is another one of Inmarsat's aeronautical satellite communication safety services, which provides with more classic services such as fax, cockpit data, and analog voice communications. Classic Aero used to operate using the i3 series constellation, but since the implementation of Swiftbroadband, Classic Aero was ported to the i4 system to complement Swiftbroadband in order to provide aircraft with all types of communication services using the same antenna worldwide. Classic Aero services can be divided into 3 different types of classic services, with each using different antenna in order to receive those services. Aero H uses a high-gain antenna and is able to provide data, voice and fax communications of up to 9.6 kilobits per second per channel. It also provides ATN, ACARS, and FANS communications with packet data rates of about 10.5 kilobits per second. This service, nevertheless, runs on the i3 network and will be shutting down in 2018 according to Inmarsat. Aero L provides both circuit switch data services as well as multi-channel voice, and although this service usually runs on i3, Inmarsat also provides this service using the i4 network. This service requires an intermediate gain antenna to operate. Aero H Plus is a newer classic service by Inmarsat, which provides with all the features that Aero H currently offers, but expands upon this in different ways. First off, it works in the i4 constellation for a more prominent feature of the service. It also works using regional spot beams as opposed to the older version. In terms of voice communication, it uses voice codecs of 4.8 kilobits per second, half of that used by the Aero H, to reduce costs on voice services. As stated by Inmarsat, all Classic Aero services offered already have ECAO's approval to be used in all ATS services and are becoming prominent in oceanic regions. This implies that many sectors such as civil aviation, business jets, and governments are currently using this network along with the Swiftbroadband as the most reliable network for communications and safety services in oceanic regions. Inmarsat's i4 constellation brings many advantages to the world of aeronautical communications. Inmarsat has proven that they can provide reliable and cost-efficient communications worldwide. First off, the i4 has the advantage of being a geostationary constellation, which provides consistent coverage worldwide, while also providing consistent and reliable signal as each satellite footprint is always in the same region on Earth. This becomes extremely reliable for communications as the user can know the amount of signal they will be able to obtain from their communications, independently of time and if the satellite is moving to other regions or not. Also, with new technologies like the ability to use spot beams, using geostationary satellites for communications such as ATS becomes more useful and beneficial due to more reliable communications and, most important of all, frequency reuse. This improves upon one of the greatest challenges we're living not only in aviation, but in almost every industry today. Also, this type of infrastructure allows for cost-effective communications over long distances without the need of thousands of stations on ground to be able to have coverage and communicate. This makes communication possible in regions where there may have been natural disasters or where there isn't heavy ground communication infrastructure. It is also incredibly cost-efficient for independent users such as individual aircrafts, as they are able to obtain both services with worldwide coverage with a single antenna, either by a high-gain antenna or its more economic option, the Swiftbroadband 200. Of course, the i4 network has some problems, and most also come from the same place its advantages do. Due to all satellites being in geo orbit, which is 35,000 kilometers above Earth, the i4 network has some latency issues due to the sheer distance. This becomes a problem in time-critical applications such as ATC communications in congested areas, such as highly transited continental areas and in airports. Overall, we can safely say that geostationary networks and the communication services Inmarsat offers are here to stay. The advantages and benefits it brings to worldwide communications and aeronautical services it provides, especially in oceanic regions, suggest that Inmarsat has a prominent future and will provide even safer and more reliable communications as time goes on. I really hope you enjoyed the video, and if you have any questions at all, please comment below. Thank you.